Hi, in this video I'm going to talk about the unified memory on CUDA applications. When we write a CUDA kernel function that's going to be executed on the GPU, and that kernel requires some memory, we treat the host memory or the CPU memory and the GPU memory as separated entities. And so before calling the kernel in the main function, usually we allocate memory on the host side and we initialize the data. Then we allocate memory on the GPU side. Then we copy that initialized data from the CPU or from the host to the device. And after the kernel finishes execution, we might need to copy the results back from the device to the host. Now, using unified memory, we can allocate a memory that can be accessed from the CPU and from the GPU, and no needs to duplicate the allocation in our code or do the copy for the initialized data from the CPU to the device, because both the device and the host can see this allocated memory, and all the required copy or allocation is done by the CUDA runtime on the background. Let's see an example. Here we have a simple kernel function that add two arrays on the GPU and store the results on the output array C. Integer n is the length of the arrays. Here we have a simple function to verify that the addition happens correctly on the GPU. Now in the main function, as we said, we need to allocate memory for all the arrays on the host side using the CMalloc API. Then we need to initialize both A and B arrays with random values. Here I assign just the index I. Then we need to allocate arrays in the GPU side for every array on the CPU side. So here we have device A or DA DPDC, and using cudaMalloc API we are able to allocate memory on the GPU side. Then we need to copy the initialized data from for both array A and B to the corresponding arrays on the GPU side. Then we call the kernel and wait for the results to be finished. And here after the execution of the kernel is done, we need to copy the result back from the device side into the host side. Then we call our verification results function to verify the result is good. Then we need to free all the arrays allocated on the host side and all the arrays allocated on the GPU side using CUDA free. Let's compile and run this function. Alright, now on the right side here we see the same version of the code, but now we will use the unified memory. So the kernel is the same in both code, and the verify results also is the same. Here in the main function, as we can see, we use the cudaMallocManaged to allocate the three arrays A and B and C, and now these three arrays are seen from both the CPU and the GPU sides and can be accessed normally as if they are arrays allocated on each side. And here we initialized both arrays A and B, and that's it. We don't need to do the cudaMalloc and the malloc 6 times here, but here we used only 3. We call the API 3 times, which is cudaMallocManaged. Then we call the kernel. Notice also here we don't need to call the cudaMemCopy to copy the arrays from the host to the device, because after we initialize the data here, the GPU and the CPU can see this data initialized. Here we call the kernel, we wait for the results, and we verify the results directly. We don't need to copy the results back to the host because the host can see the C array directly. And after that we just need to free the 3 arrays and see how many number of lines we skipped by using the unified memory. Now let's compile this code.